Hope the screen is visible.
Very clear, sir, from Malaysia side.
Yeah. Thank you. So myself, as I told you, Dr. Arokya Kumar Arokyadas, so at present working as Assistant Director, Career Development Center and Associate Professor in Design and Automation Research Group. Apart from that, I am taking care of 3 teams in VIT Chennai, Mars Rover, Technograts and Team Atom, and also Robotics Club. So quite working a lot with the students. So that's my area. Totally, I have 20 years of experience, and I have published quite articles in autonomous robots. And recently we started working on AgriDrone. So with this few information, I'll start today's presentation. So thanks a lot to the previous speaker, Professor. You have given an overall view and then the issues, limitations, and where we have to concentrate. Everything is very clear in related to IoT and also related to unmanned aerial vehicle. So my topic will be more on autonomous robots, not only drone. What are the activities we have carried out in VIT Chennai? I want to brief to you, and then you can go through and then you can ask few questions. So the agenda is today is I'm going to talk about what are the case studies we have carried out in rovers, underwater robots, and drone, and what are the research activities, particularly robotics related, which we carried out in VIT Chennai. I want to brief to you. So as like Professor Vijan said, we are 35 years old, and then we are ranked top among the private engineering institutions by MHRD India. This is our campus in Chennai. Okay, so let me come to that case studies. First, a few case studies we will see about IoT applications, how we implemented and what are the results we got and what are the scope we have to do in that particular vehicles. So the first one is about the rover. Actually, why we need is because we need robots for the area where the action needs to be precise and accurate, particularly in the area of search and rescue. Most probably this particular project, why we have started is because we want to, we have seen so many natural disasters and the collapsing of a building. So based on those inputs, so where we can use the robot that we have come across, that is, one is unclear environment, another one is, if suppose any poisonous gases or parameters are in and around, we can use this kind of robot. So what the robot has to do? The robot needs to approach unfamiliar areas. That is first thing. And second one is, it is needed for human supervision to guide it. Okay. These are the 2 areas we have concentrated in this particular case study. And this is the bot what we made. Actually, it's made in the VIT Chennai itself. And then how to remove the obstacles when the robot is moving into the collapsed building or unknown environment. That one we have done. And these are the parameters of the robot. What are the things we used? Actually, gyroscope, accelerometer, GPS, all those things. And then, so what are the things we have implemented in the project or case study? So we have implemented a walkie-talkie setup, and it's encoded audio also we have done. And then we have come across a motion detection module, and then night vision. If suppose the light is not up to the limit, so for the poor lit areas, so we have used LED, and then how to communicate that, how to get the backup stereo camera, everything we have done in this. And apart from that, without gyroscope data and altitude data, so we are unable to locate the robot where it is. So that is also one of the important parameter what we have implemented here. And then these are some of the parameters what we have calculated. As we are having 20 minutes, just I want to say the important points and then move. So what we have observed from this particular case study is up to 100-meter range, it's working fine. And then we have got the stream also by using the Flash and native browser and the JavaScript. We have used it. And then we have got the cloud and then client device, all those things we got perfect within the 100-meter range. So now the focus is above 100-meter range, how to work and proceed further. And what are the other scope of this particular case study is, we want to use these kind of robots, rescue robots, in dynamic environment, okay, by using IoT. And maybe we can couple this kind of rovers with unmanned aerial vehicle, where it will behave like a master-slave combination. So either drone will be master or the rover will be master. So anyone will behave like master and slave, and it will give a signal to us or information to us. So that is the thing we are working on that. And one more thing is we want to make it more autonomous. Those areas also we are working on that. The main thing is it has to sense the heat and then it has to be in a zero visibility area. And either it has to identify human and also non-human. So these are the areas we are working right now. The next one is about AgriRover. This is for automatic seeding we have done. Actually, we used Wi-Fi wireless controlled spraying pesticides. And what is the novelty of this one is, anyway, we used for IoT this one, ESP8266, everyone knows that Wi-Fi module. And then Gaia Geo applications we are used. And then we have come with the blank server. So we used open source most probably. And then what are the areas we are having research focuses here? That is, we used a flap servo motor mechanism here actually compared to all previous mechanisms. So this is looking much better for automatic seeding. And then the Gaia application, whatever we have proposed also, it's working well. But the problem is the video streaming and then the line of sight, because we are going to give this kind of rovers to the farmer. So it should be user friendly. So we are working on that, how best we can give it to the farmers in these areas. Okay. And apart from that, we want to enhance whatever we developed in the area of detection and the prevention of weed and pest. Okay. This is another case study. And we are working on that and we have filed a patent for this too. And coming to the third one, it's a quite interesting one. We want to see the dynamic obstacles. For example, if you are moving from one area to another, whether it's a human or a rover or a drone, or you can consider as an underwater robot, anything, any autonomous robots. So how it will identify the obstacles and how it will track it. Okay, for that we have made this particular project, and how to continuously monitor. That's the main aim of this. And we have used a PTZ camera, and then we have get all the images. Okay, this is the thing what we proposed actually. Anything wherever you want, we can keep this particular device, which is having a stereo camera, and then we have made it with a small arm. It's a manipulator actually with an end effector, and then we have used servo motors. What are the techniques we have used is actually image processing we have done, and then deep learning we have implemented here to track one particular person or one particular object, okay, till the end where it reaches. That is the main objective of this particular project. So we have done a lot of work in the IoT. So most of the students are there. So we have connected with cloud server, and then we have done an interface between the standalone robotic systems, and we have used the web server, okay, to interface the internet devices. And we got that continuous streaming in this particular case study. So, and then we know well about the cloud server and the remote client device. So those things are used in the HTTP protocol. And then the host computer, whatever we used, the stereo video feed received after all the image processed and converted into motions GP. This is the thing I want to say. For those who are interested in vision system, and you want to connect with the IoT, whether this system can be used in drone or any kind of autonomous vehicles.
Hello.
Okay.
Hello.
And, am I audible?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
I got some voice that. Okay. So apart from this, so this feed and everything we got it, and then we have used the gyroscope sensor too, and then the motions we have measured it, and we have implemented in the app actually. And based on that, we got this is the result what we got it actually. Main aim of this is up to how much distance it will recognize the obstacle very clearly with the different parameters of colors. So one is we have checked in indoor, second one is outdoor, and then in the ambient light and also low light. So the system should adapt to the environment because we are going to use it in the in and around us. That's it. So what are the results we got is actually in indoor test, everything was clear. Even face recognition, object detection and the depth mapping, everything is precise. In outdoor, when the ambient lights are varying, okay, up to 17 feet away, we are able to got the results, better results. Okay, after that we are unable to do. So now we are concentrating on how best we can go beyond this, because if we want to use in any autonomous vehicles, this 17 feet is not sufficient. We want to go for more thing. And one more thing is we have found some inaccuracies in the low light test actually. So we are working on that with deep learning and other neural network programming techniques with high-end cameras. And the third one is actually there are some problem we are facing when it is an low light area. Actually, the depth actually one color is overlapping with the other, so the obstacles distance we are not getting it properly. So those things we are thinking about how to implement proper lighting techniques or proper algorithm to get a better results. So this is the another one. And coming to underwater applications. So we have started with a small glide bot, and this is the arrangement of that. The three hinges will be there and screw mechanisms. These are related to the mechanical and the mechanisms concept, and how to connect the motor, all those things. And we have used that ITTC 1957 equation, and we have developed this particular glide bot. So what is the aim of this one is it has to undergo in water, and for a particular period of time it has to go and stay there, and then it has to come back. That is the aim of the project. So we have done with the low cost everything with the starting to end actually. And these are the findings what we got from the design point of view, that is computational fluid dynamics we have done. Because any design related to the underwater, we have to come across the drag and lift of the vehicle. Not only underwater, any autonomous vehicles which is moving in a land or air or water. So we should do all the force related analysis. So we have done it, and we got quality results from that. Based on that, so what are the outputs we got is it is working fine up to the certain depth, actually up to 6 feet or 7 feet. It is going continuously, and then it is waiting for some seconds, and then it is coming back. So the program we have done by using Python, and then we have tested various tests. But what are the future scope of this particular robot is actually? What we planned is we want to use it in a normal pond to check various parameters of the water. But now we are looking for that, shall we implement the same techniques such that the glide bot will go to particular distance in the ocean, and then after some time, maybe half an hour or 1 hour, it has to sense in and around everywhere, and then it has to come back by its own. Okay. So we are working on that. And second one is we face some issues in the signal communication actually. Even though it is autonomous because it's programmed, but we face some issues in getting the continuous stream of images or video. So we are working on that. So initially we send with the SD, that is some memory devices with that, and then we got the results on that. The quality of the images and everything is perfect. It's under development, and we are going to apply for patent. So I couldn't give some of the images of that. And second one is this one is we used another method for making a same underwater robot, but at the same time how to avoid the obstacles. So that is the main aim of this. And same thing, we have done a model, and then here we have optimized the parameter of the underwater robot based on the nose radius, fin size, and number of fins, and then we have used the equations, and then we have developed the code, and then we have finalized which hull design will be better and which fin design will be better. So based on this, we have come across the basic properties like drag, lift, all those things with various angle of attack. So next one, actually, we have developed another underwater robot with the for pipe inspection. This is also for ocean application only, or wherever the oil and gas industries are there. So we developed that, and these are another related study. I think Mark Owens, and then we have combined, and then we have done some simulation studies on this. And then we got better results. And then where we are facing issues is whenever we are designing this kind of underwater robot, the stress creation is so important, because we know that ocean application, the pressure will be too much. So we are working on different materials now, and at the same time, when it is gripping, we know very well that gripper is cantilever beam structure. So a lot of issues are happening there. So we are working on that particular design, so that if you are interested, it will be well done. Okay. Apart from that underwater robot, we got some interest on biomimetic only, and we have made one fish for that, monitor the pH level. So this design, actually we used a 3D printer, and then we have created everything in IIT Chennai. As usual, IoT we have applied on that, and then we got results of various movement of the fish, and then the fish also sends the various pH value, and then it has given to our mobile. So that's nothing but IoT. What issues we faced is, as like I said, the time delay. After getting a signal, it's 1.5 seconds delay we are getting each and everything. So we are working on that, how best we get the results at the earliest. And this is another one in underwater boat. We used a CFD for simulating this. The studies are going with respect to the design and the propeller and how effectively we communicate it. That's the thing we are working on that. And these are the parameters of vehicle. And what is the feature scope of this particular obstacle avoidance dynamic meshing? So the people those are working in design, you know very well that instead of static meshing, we are going with dynamic meshing. Depends on the environment, the structure will begin. According to that, the pressure and the thrust and lift and everything will vary. According to that parameter, we want to design an underwater way. That is the thing. It's going on now. One research scholar is doing the project. Okay. So coming to drone area, that's quite interesting. What we have here is we have developed a drone called Narad. Actually, it's a multi-purpose drone, and the drone can operate on land, water, and all that. So it is called as IBBM drone. Here we concentrated more on design. Actually, what we done is first we have developed a thrust RPM speed, how it is varying. So we used a MATLAB with the approach. We have done a coding with equations, whatever we got, and then we have checked that which thrust and what speed parameters will be good to design a drone for land and also air and also wherever we want water. And this is the design actually. So here actually we proposed a V-shaped design to get a better structural integrity, because in land it has to come in a normal way, and in water it has to be the wing should be like a fins, and then in the air it will be in a normal drone. So what we have proposed is the entire fins will be like V-shape, so that it will flexibly move in within a degree, that is from 180 degree, it will 90 degree and 90 degree clockwise and counterclockwise can vary. And we have limited to 45 to 45 degree because that is sufficient for moving in a land, air, and also in water. So we have proposed that. This one we have analyzed by using the SolidWorks. And then we have come across that what are the stress parameters, even though we are applying a load, and it has to be in land, air, and also water. So we have given all the input parameter to the fins, and then we have planned that how it will fly. So how effectively these parameters will be considered to make a better design of the drone. And this is the landing also. We have done the analysis. The total load we have taken and then we have applied. Anyway, it's a symmetry in nature. So we have analyzed for only one of the frames. So remaining things will be same. And then practical test we have carried out after varying the fin angle. And then we have found it's good actually. We are still working on that. So we will proceed further with IoT techniques. And we can use it for this one for sunflower farms, and then get the details from the images, and then we can process so that pesticides and other things can be sprayed in a higher level. So what are the scope, if you are asking based on whatever we have done in VIT Chennai? So still we are facing a problem in underwater autonomous vehicles. One is capturing images in real time and the video streaming, as I told you. And second one is the prediction of orientation and navigation of underwater. And the third one is the time delay between collecting and sending the data. So we are working on that. So if you are getting any help, we can proceed further on that. And regarding to the UAV, so on-field localization, we are facing some issues. And apart from that, the GPS coordinate, and then the sending message and receiving message with IoT technology, with high end, we are working on that. And still we are looking for the better algorithm for getting exact information in low cost. And one more thing is, at present we are working on these areas, the IoT and smart farming, that is management we are working. So we started collecting various details, these parameters. Otherwise we can say in deep learning or any neural network method, data we are collecting for various plants, so that we can optimize and then we can give all these details to the unmanned aerial vehicle so that the farmers will get benefit. And the pest control also we are using, we are start using PAR sensors, and then how to control using herbicides also we are thinking about it. And the patents, so what we have filed based on the autonomous vehicles, what we have done. And all these things are along with the students. And these are the research activities. Anyway, you have seen the conceptual design of Narad. And IoT in robotics, yeah, I didn't come across this. Actually, we have developed a AgriBot for roof gardening applications. We have filed a patent on that. And upon that, we have done IoT controlled mobile robot for home security. And apart from that, we are working on some industrial robots. And this is one of our main area, rover design. And recently we got 5th rank in Master Society of USA. Then we are working on healthcare rehabilitation robotics also. It's related to the manipulated design. And I'm having around 120 students in my team. Here few are there. Yes.